So this week, we're going to finish up with 10.5, which is on graphing. All right, so we've done graphing points. Okay, basically, in this section, we're going to do the same thing. We're going to graph points, but we're just going to connect them. Okay, we're just going to draw a line through the points, and that's it. All right, so remember yesterday I showed you guys some pictures on the calculator, how to draw like a straight line? Basically, that's what we're going to do by hand. Just going to draw straight lines.
Do you have any rulers?
Yep, you can just use your ID. Just use the edge of your ID. All right, so let's look at this equation. Okay.
Hey guys, you're not, this first page of notes that Mr. Hager's doing right now, you're not going to have to write anything down. We're just listening right now.
This equation says x plus y equals 3. Okay, so any two numbers that add up to 3 is an answer to this problem. Somebody give me a number for x and a number for y that add up to 3.
1 and 2. Wow.
Sure.
2 and 1.
Yeah, that's all. That's different. That's a good point. Okay. You could let
Wait,
x.
can you use negative too?
You could use negatives. You could use fractions. We try to stick to numbers that are easy to work with, though. Here's another one. X could be 3. Y could be 0. Any of these, if you plug them in for x and y, will add up to 3. Okay. Does everybody see that? All right. And again, there's thousands, millions of points you could pick, but we try to pick ones that are small numbers, easy to work with. All right. I listed some other ones. Okay. You guys already got some of the ones I had. 1, 2. Okay. 0, 3. That's not one I listed. I had 3, 0. That is different. Okay. 2, 1. We had that one. Okay. We had that one. Okay. And somebody said, can't you use negatives? Yeah. If you take 4 and add negative 1, what do you get? You get 3. So all of these points are answers to this equation. If we can find a few answers, maybe like 3 to 4 answers to this equation, we can graph those points, and then we can take and put a line right through them. All right? So that's basically the idea of what we're going to do. Find a few answers to an equation, put those points down, and draw a line right through them. Okay, notice here too, none of these first coordinates repeat. What does that mean? If none of the first coordinates here repeat? It's a function. And now what shape did I say that this is going to make when you draw it? A straight line. Okay, so if we put those two words together, okay, this is not only a function, it's a function, that's a line. Okay, so we call that a linear function. Okay, it means a function that's a line. Okay, you get the word line right there. All right, any question on that? Okay, so a line, that's a function, a linear function. Okay, there's other kinds of functions too, things that are curved and gets more complicated. But we're only going to look at things that are straight lines. Great. Any question on that? All right, so now when we have an equation like this is okay, but what letter do we usually like by itself on one side? Yeah, sometimes we get x when we're solving an equation, but think of like y equals mx plus b. What letter is by itself? Y. All right, so our goal, our first step, anytime we have an equation like this, is going to be to get that y by itself, put that x on the other side, okay, and write it in that form. How many people have heard of y equals mx plus b? That's basically our goal. Okay, we're going to get it in that form. Okay, so Mr. Roy is going to show you guys how to do that.
That's the first thing we're going to write on our notes, all right? So the goal, like Mr. Hager just said, we want to get y by itself on the left-hand side of the equal sign, followed by the x. Sometimes, most of the time, that x is going to have a number with it, but sometimes it might just be x by itself, a plus or minus sign, and then just a number at the end. So it might look like this. Y equals, there's my y on the left-hand side, there's my equal sign, then on the other side I have my x, in this case I have a number with it, I have 2 with it, sometimes it might be x, sometimes it might be minus x, and then I have plus or minus sign, and then 3. We want to come out like that. There might be a couple exceptions. Sometimes there's special cases, and we want to talk about that at the end of notes today, where you might just have y, the equal sign, and then just an x. Or you might have y equal sign and just plus or minus a number, right? But most of the time, in most cases, we're going to want it like that. And like I said, when we get to the end of our notes, we're going to talk about those special cases and how you graph them. So y equal sign x plus or minus and then a number. That's the order you want to follow. So I know you guys are still writing, but as we move on here, Ms. Hager and I are going to show you that when we're doing these, there's certain types of problems that you're going to have where you're going to have to move some stuff around to get it in this format. Now, most of the stuff we do from now until probably like January, even February time, it's all going to be based on this. It's all going to be based on getting that y by itself. Rosie.
I know that probably my math teacher used to taught it to us. He called it y equals mx+b.
Exactly. And we're not quite at that point yet, but we're going to start talking about that next week. But we want you guys right now to start getting into the habit of setting it up like that. And so when we get into it next week, it's going to make your life a little bit easier. All right, guys, I'm going to scroll down a little bit. Now, if you're going to graph something and it's like this, great, you're all set. Y is already by itself. I got my equal sign. After the equal sign, I have an x. Then I have my plus or minus, then a number. It's all set to go. It's in the right format. There's nothing I have to do to rearrange this to get it ready to graph. It's all set. Nothing I have to do. Now, I might get something like I got a number with, let's say a number with x. Number with x on the same side of the equal sign with a positive y. So I'm going to have a number with x on the same side of the equals. I think that's, didn't it say that on here? Okay. You guys had that on yours. I just didn't change it on here. So you have x on the same side of the equal sign with y. Sometimes x might be by itself. Sometimes it might have a number attached. All right? So I want you guys to write that equation in that little box there. So you might have something that looks like this. I might have x plus y equals 3. So I have an x on the same side of the equal sign with y, and y is positive. All right? Everybody's got this? First thing I want to do, when I have something like that, x on the same side as y, and y is positive. I want to do the opposite operation of x on both sides of the equal sign. So whatever sign is with that x, I'm going to do just like we did when we were solving equations. I'm going to do the opposite of that on both sides. That way I'm going to cancel it out on one side, and I'm going to show you how to write it out on the other. All right? So below where you write that step, you're going to write that equation out again. Because now you're going to have an example with the actual steps and how to do it. Okay? So it says do the opposite operation of x on both sides of the equal sign. Victor, what kind of an x do I have?
Positive.
Positive x, right? There's no sign to the left of it, so like we talked about since the beginning of the year. It's just the way it is. We assume that it's positive. So what am I going to do, Victor?
Do you have to subtract?
I'm going to subtract x. Exactly. And it's addition. Subtraction is the opposite. So I'm going to minus x. Where else do I have to minus x from? Everybody tell me?
3.
Minus x from the 3. Now, this is fine. What's going to happen to this, that positive x and that negative x? Victor?
Cancel out.
That's the whole reason. Again, I told that class last year, guys. I'm not minusing x just for like, hey, you know, I really like math and I want to minus x. How come I'm minusing x? Why am I subtracting?
I'm trying to get y by
I want to get y by itself. Good, Sabrina. So that's going to cancel out. I'm going to be left with, here's my equal sign. On that left-hand side, what's left? Y by itself. No number attached, no negative sign with it, just a y. Now I'm starting to get in some good shape here. Y equals. Now, can I solve 3 minus, who says I can solve 3 minus x? Anybody out there say I can do the math and come up with an answer for 3 minus x at this point in time? Okay, I can't. How come? Victor?
Because there's no other variable.
There's no variable. When they're the same, what do we call them all year? Anybody remember? When they're the same thing? And I can put them together? Like terms. Good. I can't combine like terms. I have a number and I have a variable. It's not possible. So we go back to the beginning, right? The goal. After the equal sign in that format, what needs to be there? So we're going to have y equal sign followed by what? Victor?
Maybe negative 3x.
Not negative 3x. I'm not going to combine them. Anybody else want to take a shot at it? Rose?
Y equals 3 minus x.
No. Maria?
y equals x plus 3.
So, Maria, you're super, super close. You missed
Minus
one.
3?
No, not minus 3. What is the minus attached to? The x or the 3?
The x.
The x, right? So it's y equals negative x plus 3. Whenever I have that x on this side, when I rewrite it or when I move it, it has to go after the equal sign. That's the order it needs to be. It needs to go. So you can think of it. Sometimes what I'll do also, I'll take it and I'll circle it and I'll draw an arrow to the other side of the equal sign. Sometimes that makes more sense for people. So now I have the order that I want. I have y equals negative x plus 3.
Did anybody think 3 minus x? Is anybody thinking that? Yeah, it's not wrong. It's just
It means the
not-
same thing.
It's the same thing. It's just not the order we're looking for. 3 minus x is correct, but we want to put the x before the number.
We always want, when we have something like this, when we have x on the left-hand side with y, we always want to put it after the equal sign. We want to take it and write it after the equal sign. All right? So when we have something like that, y is positive. There's nothing attached to the y. There's no coefficient or anything like that. That's all you would have to do to get something like that ready to graph. That's the format we want. It's all set to graph. All right? Now, that was only one step to get it ready to graph. What we do here is going to be 2 steps. So now we got same thing, x on the same side as y, and we're also going to have a number attached to the y. We're going to have a coefficient. It could be negative, it could be positive, it could just be a negative y. All right? I'm going to give you 2 examples here to take a look at. All right? So we're adding another step. We get x on the same side, but now we also have something attached to the y. So this one, we're going to have 2 things. You might have something that looks like that. Negative 6x plus 2y equals 10. Or you might have something like x minus y equals 9. Again, both cases, I got something on that left-hand side with y. And in both cases, this one you might not know. Well, Mr. There's really nothing attached to y. I'm going to show you. This one, Mr. Hager and I see kids slip up all the time when we have something like this. So I'm going to show you that. So, first step, same as before. Same as we did for the other one. When we had x on the same side, but y was positive. We're going to do the opposite operation of x on both sides of the equal sign. We're going to do the same exact thing as we did for the first one. So if you want to put, you can write this. If you want to write same as above, that's entirely up to you. But it's going to be we're going to do the same exact thing as we did for the example that we had above. Because we're going to get the x move first before we do the next step. guys, as I'm going ahead, that'll still be up there if you're not done writing it yet, okay? So I'm gonna write those two equations again. I'm gonna have the negative 6x plus 2y equals 10, and I'm gonna have x minus y equals 9. Those are the same exact equations I had above. All I'm doing now is I wrote them again so I can actually show you the step. So you'll have the step, and you'll have an example below it of what to do. Okay? So, it says do the opposite operation of x on both sides. So for this first example, who can tell me what's the first thing I'm going to do? Who knows? First thing I'm going to do for that negative 6x plus 2y equals 10. Kevin. Add what? What's it? I'm going to add, so I'm going to add negative 6x. So I'm going to do this. Add negative 6x. Is that what you want to do? What do you want to do? So what am I going to write? If it's negative 6x, what should I do? I'm doing the opposite operation. What would the opposite be? It's negative here. What would the opposite be, Kev? Yeah, so I'm just going to add 6x. And I'm going to add 6x over here. So, here's my equal sign. Left-hand side. Left-hand side over here. What's left? I can put plus 2y or just 2y. It means the same thing. But that's, Victor, that's really good because that sign that's attached to it is still coming down. If it was a negative there, I have to bring the negative down. In this case, it's positive. I don't have to write positive 2y. I know if there's no sign there, that it's positive. So I'm just going to put 2y here. Now we get to what we talked about in that first example. What's going to come after that equal sign? Caitlin. 6x. Again, it's positive. I don't have to write plus 6x. If there's no sign to the left of it, I know it's positive. So 6x. What's the sign going to be with 10? Positive or negative? Positive, right? There's nothing up here with it, right? It's just 10. So we know that it's positive. There's no sign to the left of it. We assume that it's positive. So for this one, I'm in good shape. I'm not done yet. Who can tell me why I'm not done yet with this one? How come I can't graph that yet? Anybody know why? Caitlin. Y is not by itself. How come, Caitlin?
Because it's attached.
There's a 2 with it, right? So I'm not done yet. We're going to get to that in the next step. Over here, this guy. Samantha, you think you might know what you want to move? How you want to move that x? How you going to do it? Subtract it. Good. So I'm going to minus x. Draw my line. Equal sign. Left-hand side. On the left-hand side, Victor, I'm going to ask you for this one because you helped me out in that last one. Think about what I said when you told me the last one. Remember you told me that 2y, that positive 2y? On that left-hand side, what's left?
Negative y.
Nice. We got to bring that, if that negative sign's attached to it, to the left, I got to bring it down. So it's negative y. After the equal sign, what am I going to get? I didn't do that over here. I got ahead of myself. After the equal sign, what am I going to have? Tell me. It's big.
X plus 9.
Nice. Negative x plus 9. I took it. Every time I move it, it's going to go after the equal sign. Every time. And then I have my sign and my number. So I'm getting to where I want to be. I'm getting to where I want to be. Now, like I told you before, this is 2 steps. First step, just like before. Move, do the opposite operation of x, get it to the other side. Now, I'm going to divide, there's 2 things that can happen here. Or 2 different situations. I'm going to divide everything in that problem. I'm going to divide everything by the number attached to y. Everything has to get divided by the number attached to y. Same kind of thing, but it kind of tricks people sometimes. Divide everything by -1 when a negative sign is the only thing attached to y. Like we have in that second example. See how we have a negative y? That means negative 1y. We just don't write the 1. Sometimes you guys will know in your homework and stuff like that, but in the book, on a test, homework, something like that, it's going to be negative y. So when you have a situation like that, when negative y is the only thing left, you divide everything in the problem by a negative 1. Sometimes I know when I've been working with kids, that's something that they forget. They forget that the y is they think they're done, but y is still negative. Then they go and graph it, and they get it wrong because they didn't divide everything by a negative 1. Last one. So once we do this step, then we'll be set the graph. And guys, most of the time, these are the two main types of examples that you're going to see. You'll see something when you have an x, like we did in the first one, x on one side with a positive y, move the x, you're done. Or you might get something where you have x with y, but then y also has something attached to it. Those are the two main types. And then, like I told you at the beginning, those special cases, we're going to talk about those in a little bit. All right? So, what I'm going to do, I'm going to take what I got, how I finished off step 1, and I'm going to bring it down to start step 2. So this is what I was left with. 2y equals 6x plus 10, and I got negative y equals negative x plus 9. So the step 2 says divide everything by the number attached to y. So for this example here on the left-hand side, what do I have to do? Who can tell me? Samantha? Divide 2 by everything. So I'm going to get 2y divided by 2. What else am I going to get, Samantha? 6x divided by 2. And positive 10 divided by 2. All right? So, this is the whole reason why I divided by 2 was for what to happen. Why did I do that? To get y by itself. So I know here, these are going to cancel out, and all I'm going to be left with is y. And some of you guys might say, well, Mr. Roy, 2 divided by 2 is 1. Yeah, it is. But I don't need to write 1y. It's like, you know, if you have a buck, you don't say I have 1 buck. You say, hey, I got a buck. All right? So all I'm left with is y. Now, 6, remember, we're dividing, right? So 6x divided by 2. What do I get? 3x, right? All I'm doing is just bringing the x down because there's not another x there. So I'm going to get 3x, and I get a positive 10 divided by a positive 2. What do I get? Positive or negative? Positive. At that point, for that example, I am ready to graph. Y is by itself. I have the equal sign, x, sign, and then just a number. I'm in good shape. Now, you all set, Gage? You all set over there? All right. Now, this one. What am I going to do on that one? That's following that special rule. I got a negative sign with y. So what I have to do, Caitlin? Divide by negative 1. This is a tricky one. Divide everything by negative 1. Oops. The reason why I did it was to get y by itself. I'm going to be left with y. Now this is when it gets a little bit tricky. I have a negative x divided by a negative 1. What do I get? Anybody know? Logan. Positive x. I can write 1x, or I can just write x. A positive 1 divided by, a positive 9 divided by a negative 1. What do I get? Negative 9. Not subtracting. Negative 9. Good way to remember it, guys, when you're doing these. All right? If the top and the bottom are both negative, it becomes positive. Just like this. Top and bottom both negative becomes positive. Same thing here. Then if I have the top negative, the top positive and the bottom negative, the result is negative. Same thing vice versa. If the top was negative and the bottom was divided by a positive, it'd be negative. Remember your rules for dividing. All right? And we're not going to get too into that today. But again, now both of these, y by itself, I have the format I want. All right? Everybody has this down? Okay. Good. Next thing. Once you get y by itself, you're gonna see on your notes. I don't want to make. You're gonna use this chart. All right. You're gonna use that chart. You're gonna use that little chart to help you set up your graph. First thing we want to do, we're going to choose values for x. Most of the time, we want to make them small. All right? Sorry, I'm going to go back real quick, guys. So that was one of the equations that we had for that one of the last examples that we did. All right? So, guys, your chart, I'm just showing you how this works. Your chart's so small, you're not going to have room to fit this in. I just want to show you how it works. So, we're going to choose values for what? For x. Like Mr. Hager was saying in the beginning, make them small. Try to make one negative, try to make one positive, and maybe one could be 0. Because then if you're multiplying, it's numbers that you know how to multiply. So, in my x column, I'm going to write these numbers in. -2, 0, 1.
Yeah, we're probably going to use those numbers for every example. You don't have to, but pick very easy numbers. Don't pick x like 307. You could, but you're making life hard.
And the graph's not going to be big enough to fit the points on. Now, see this blank right here? On all your little charts or little tables, it's going to be blank. What do you think is going to go there? What do you think I'm going to write in there? I'm going to write in there everything after the equal sign. I'm going to actually put my equation in there. 3x plus 5. All right? Then I'm going to, these numbers that I chose for x, -2, 0, 1, I'm going to plug them in to the equation for x. They're going to become, I'm going to evaluate. All right? So I'll do the first one. It'll be y, parentheses, -2 plus 5. All I'm doing is taking those values I chose for x and plugging in where I see x in that problem. My second one, for 0, what would that look like? Caitlin?
3 plus 5.
Yeah, again, 3 parentheses 0 plus 5. Gage, that last one, how would I write it out for 1?
3 parentheses 1 plus 1.
Perfect. So now I got them all. I have it all set up. I went through, wrote my equation in, plugged in. What I would do is set them all up first. Plug everything in first. Then kind of like we did yesterday. All right, we did stuff like this yesterday. Now we're going to do the math and we're going to solve for y. So I'm going to get 3 minus -2 is what? I mean, 3 times -2 is what? -6, and I'm going to have a -6 and a +5. What do I get? -1. So I'm doing the math in here, and that's going to give me y. Because that's the whole reason why I got y by itself. Because now I can solve for it. I got 3 times 0 is what? 3 times, anything times 0 is 0. 0 plus 5. 5. Good. And then 3 times 1? 3 plus a 5? 8. Last thing. We're going to write what's in my x and my y column as an ordered pair. So my first ordered pair would be what? negative 2, negative 1. Davin, what's my second ordered pair going to be?
5 and 0.
Careful.
Oh, 0, 5.
Right, here's my axis here. Let's be careful. 0, 5, but you're looking in the right space. Last one's going to be what? Michaela? 1 and 8. And then all I'm going to do is, I'll take these coordinates and graph them. That's all I'm doing today. So most of the time, the hardest thing is getting y by itself. Once you get y by itself, you're just doing some basic arithmetic here. And some of them you may not have to. Some of them, I think, there's one of the tests where it's already set up for you. You don't even have to get y by itself. Victor, question.
On the test, how many questions are they going to be for this?
It's like 20 something tomorrow.
This certain
2 or 3. 2 or 3 maybe. All right. Do I have anything up on him, Hager? I don't think. That's it. So once I'm done filling that chart, that table, I can graph those points. All right. We're going to do a couple of examples.
All right, so kind of directions you're going to see on a problem like this. It'll say graph. It'll give you an equation. Okay, first question, is this ready to graph? Is this the way we want it to graph? Callan, no? You said no? Why not? Yeah, you're supposed to have the y by itself. All right, so anything that's not y, we've got to put on the other side. Okay, this one's not too bad. Anybody tell me, what do I have to do to get y by itself? One step. Yep, Sabrina? I'm going to add 2x. I'm going to add it here, and where else? And to the 1. Okay, Corey, negative 2x plus 2x. That's gone. What did you say? It cancels out?
It's not very wise. It's just y alone.
Yeah, y's alone. Good. And what am I going to put on that other side?
Y plus 2.
Okay, y's on the left, so don't worry about that.
1 plus 2.
Okay, Corey says 1 plus 2x. Yeah, I like, it's not wrong, we just want to get it in a different order. Okay, we're going to go with 2x plus 1. Okay, so like Mr. Wright said, you always put it right after the equal sign. Okay, the term with the x. All right, now are we ready to graph? What do you think? Kevin?
All right, it's at the table. Kevin, stop writing stuff down.
Yeah.
Come. What's the whole goal? Gabe read your mind. All right, he said get y by itself. We got y by itself. Perfect.
All right, now to graph it, we need a few points. Okay, what would be some good x values to pick? Okay, you can pick anything you want, but don't make my brain hurt. Don't make me do hard numbers for x. Try to pick a negative, a positive, and maybe 0 is a good one too. Yep? 5? 5's okay. Can we go with 4? 4 at 5 will just be off my graph. Otherwise, I'd say, yeah, use 5. Okay, 4 is okay. Yep. Yep, what else? Yeah, negative 1 is good. And let's pick one more. Rose?
5.
5 is going to be off my graph.
0.
0, that's fine. All right, that's still off the graph.
It's 5. She was hoping maybe she asked, maybe you'd say yes. But
Maybe I changed my mind. Yeah. All right, now what do we put in this blank space right here? And don't put your name. It's kind of a joke. Everybody get that? Yeah. Yeah, put in the 2x plus 1.
again, you don't have to put the y, guys. All you do is put what comes after y equals.
Okay. Now this expression, this is your directions for how you're going to find y. So what do I have to do with each of these x values? One at a time. Plug them in. Maria, can you just tell me what it looks like when I plug in my first one?
2 parentheses 1
Plus 1, that's good. Jalen, can you give me my second one?
2 in parentheses -1 plus 1.
Yep, we're just setting up all our work we're going to do. Ariana, can you give me my third one?
2 parentheses 0 plus 1.
Plus 1. Good. Right, we've got our formula for how we find the y. Now we're actually going to evaluate. Okay, Alex, what's 2 times 4?
8.
Plus 1?
9.
Good. 9. Okay, Brian, what's 2 times negative 1? Yeah. Positive 2 times negative 1 gives me negative 2. Right? 2 times negative 1, negative 2. And then plus 1. Yep. Negative 1.
You guys, you can punch that equation part, you can punch that right into your calculator with the parentheses and everything. It'll just do it for you.
How about this last one? 2 times 0, Ariana?
0.
Plus 1? 1. Okay, so now we've got our x's, we've got our y's. Let's write them as ordered pairs. Okay, what's my first ordered pair? Ryan.
That would be 4 and then 9.
Good. 4, 9. Okay, my second ordered pair, Zach. Nice. Negative 1, negative 1. And my last ordered pair, Kevin?
0,
1. Okay. Now the last step is to take these points you just got, graph them, and that's going to give us our picture.
graph this.
We're going to graph it, right? This is what we did on Tuesday. 4, 9. So right 4, up 9. Okay, the next one, negative 1, negative 1. Left 1, down 1. Okay, and the third one, just go up 1. Right, and it should look like all those points are in a straight line. They look good? What do you think? Yeah. So last step, make our line.
Whoa.
It'll be okay, don't worry. Right, and there's our line. And that's it. So that's kind of the final step. So as far as problems like this on the test, where you got to rearrange it, get the points, and graph it, you're not going to have to do a lot of these. Maybe 1 or 2 at most. Okay, any questions on what we just did? All right, when you draw your line, even on the test, okay, we'd like you to make sure you use either a ruler or use your ID. Okay, make sure it looks good, nice straight line. All right, let's try this one. Okay, this is similar to the second one Mr. Roy did with you. Okay, the one where you just have that negative in front of y. Okay, who can tell me my first step to start getting y by itself? This one actually has 2 steps. Yep. Good. Subtract x. Subtract x. Okay, that's gone. Maria, what am I left with on the left side? Negative y. And who can tell me what's on the right and try to put it in that order we're looking for? Yeah, Kevin? Negative x plus 3. Perfect. All right. Question. Do we have y by itself? No, we got one small thing left with it. Okay. After Mr. Roy's expert tutelage, what did he say to do when you have a negative with the y? What do I do with a negative 1? You said use it. Sabrina? Yeah. Divide everything by negative 1. Okay? That's going to cancel out that. So now we got y by itself. What's negative x divided by negative 1? Yeah, just x.
Yep.
These
On the
negatives
bottom of
cancel
both
out.
negative, it becomes positive.
Positive 3 divided by negative 1. negative 3. Now, we got our equation ready to go. All right? So again, let's pick some values for x, but keep them small enough that we can do in our head. 2, that's good. Another good value?
0.
0 is good. And one more, Rose.
Negative 3.
Negative 3, that's fine. Yep.
No 5 this time.
Yeah, you could have used 5 this time. It would have been okay. Would have fit on my graph.
Negative 5.
Let's do negative 3. That's fine. All right. So we got our formula. How about, Victor, can you tell me what's it going to look like when I fill in my first value for x? What do I put?
2 minus 3.
2 minus 3. Next one is 0 minus 3. What's the last one?
Negative 3 minus 3.
Yep, negative 3 minus 3. Now we got to do those out. Callan, what's 2 minus 3? Negative 1. Caitlin, 0 minus 3. And negative 3 minus 3. Be careful here. Yeah? Negative 6.
If both negatives, keep the sign, add them again.
Okay, and now write your coordinates, and that's going to tell you how to draw the picture. Gage, what's my first coordinate going to be?
2 and 1.
2 and,
Negative.
yeah, negative 1. Okay, Zach, my second coordinate? Good, 0, negative 3. Alex, my third coordinate?
It's negative 3, negative 6.
Good. Only thing left to do, put those points on your graph, draw your line. Okay, so we're right 2, down 1. This one, 0, negative 3. What do I do for that? Yep, start from the origin.
Then go down 3.
And that's it. Down 3. And the last one is left 3, down 6. Left 3. Okay, make sure it looks like they all line up. Looks good. Draw your line. Okay. Any questions on that one? All right. Does everybody have that? All right. Sometimes they're going to ask us to do the same thing. Okay, it's literally going to be the exact same problem. They're just going to write the question a little differently. But you don't have to do anything different than what we just did. So let's say you were given something like f of x equals, let's just go, let's try using actual letters, 2x plus 1. Okay, that's exactly the same as this. Okay, I don't want you to be fooled by them writing this. Okay, if they write f of x equals 2x plus 1, that's exactly the same thing as if they had just put a y here. Okay, why'd they do it different? Who knows? It's just a different way of writing the same problem. All right. Here's another example. If we ask you to graph f of x equals 3x minus 8, that's exactly the same as y equals 3x minus 8.
So guys, on your notes, you have like the f of x, fill in 3x minus 8, then below it you have the y equals, you know, the same thing, 3x minus 8. And then a little bracket there, you're just going to put same.
Okay, so what I do, if I don't want to get confused, just change f of x to y.
Yeah.
So on the test, if you see a problem, f of x equals, and you don't like it, just cross it out and change it to a y. And then it's exactly like the problem we just did before.
And then guys, then you have below where it says change, you're just going to put f of x to y.
Right. So if you have one like this on the test, it says graph f of x equals negative 2x plus 1. what's the first thing I could do to make this written in a more friendly way that we like?
Change f of x to y.
Yeah, change f of x to y. So what will my equation say?
Y equals negative
y equals
plus 1.
negative 2x plus 1. Okay? And that's it. Now just do it like you'd normally do it. This problem we made a little easier. Y is already by itself. So now you can just go right to the table. Pick 3 small numbers for x.
1, 2, 3.
And then we graph. Yeah, try to pick one that's at least in the negatives.
1, 2, negative 3.
So yeah, we could do 1, 2, and negative 3. That's perfect. Okay, you guys get this one on your notes? You got it? Is it the last one?
Yeah.
Okay. All right, so there's a couple after this. I think Mr. Weiss just got to get the other sheet. All right, so does everyone have what's on the left so I can make the right bigger? All right. So we got 1, 2, negative 3. What's my formula that I'm going to fill in the empty box?
X minus.
Michaela? Yeah, negative 2x plus 1. All right, and then what I'll do, just to help you guys out, I'll fill in all the numbers. So we have negative 2, fill in a 1 for x. Okay, then we've got negative 2, fill in a 2, plus 1, and then fill in a negative 3. Okay, do our arithmetic out. Okay, negative 2 times 1. Kevin, what does that give me? Negative 2 times 1.
Negative 2.
And then plus 1. Negative 1. Good. All right, there's our first one. Second one. Rose, what's negative 2 times 2?
Negative 2 times 2 is negative 4.
Good. Negative 4 and then plus 1?
Is
Negative 3. Nice. All right, and last one. Negative 2 times negative 3. It's negative 2 times negative 3. Yeah?
negative 2 times negative 3 is
Positive 6 plus 1 is 7. Okay, lastly, write your coordinates. 1, negative 1. 2, negative 3. Negative 3, positive 7. Okay, and then you'd make your graph. Okay. For this one, I'm going to skip the graph so we can get to the last 2 examples you got to get to. Okay, any questions on the table there? All right, so the only trick here, change f of x to y. You're good to go. All right, so the last thing we're going to look at is 2 special cases of graphing. Okay, do you guys have this?
No.
Oh, no. Slack.
All right, so all the lines we've drawn so far have been on an angle. Okay, we haven't had a line that's been straight up and down, and we haven't had one that's been straight left and right. What do you call a line that's perfectly up and down? What do we call that? Vertical, yeah. All right, so vertical is a special case. Okay, vertical and horizontal lines, they kind of break the rules that we gave you earlier. They're easier, but they don't follow the same rules. Okay, vertical lines always look just like this. There's no y. The y is gone. Okay, it's just an x. It's x equals a number. Okay, so this is a special case separate from everything else. You just have to remember. If you just have an x, an equals, and a number, it's a vertical line. Okay? There's no y. There's no y. Okay, so this first one here, this would be a vertical line. And what number do you think we would put the vertical line at? what number? 2. This one would be a vertical line, and we would put it at the number 2. Okay, so if you were going to graph it, you had your graph paper set up. Where's 2? How do I get to 2 on the...
Move to the right 2 times.
Yeah, go to the right 2 times and put in a vertical line. That's x equals 2. X equals -3. It'd be a vertical line. What number do you think it would go through? What number? That's a negative.
Oh, okay.
Yeah, -3. All right, so it'd be a vertical line at -3. All right, so we'll try a couple more of those. What other case you think I have? I have vertical and which ones? Yeah, I got horizontal. Well, if vertical was x equals and a number, anybody have a guess what horizontal is going to be? Someone said it? Y equals and then a number. Okay. What letter is missing here in the horizontal? The x is gone. Okay, these are special cases. In horizontal lines, it's just y, an equal sign, and a number. Okay, y equals 4. This would be a horizontal line. At what number? Yeah, it'd be a horizontal line at 4. How about y equals -8? You go down 8 and then put a horizontal line. Okay. Any questions on the 2 special cases?
Yeah, so all you're doing is whatever it says, x equals, find that number on that axis. So like find 2 on the x-axis and draw your line opposite of the axis. Don't draw it right on that axis, you're not going to be able to see it.
Okay, so what about this one? Y equals 3. Horizontal line or vertical line?
So guys, you have those 2 spots for graphs there, just write these in that spot,
Rose?
in the same
It's
area.
gonna be a horizontal line.
Yep, horizontal line.
All right, right there.
So it's going to go left to right. What number is the horizontal line at? Yeah, go ahead. 3. So I go up 3. And I'm going to put in a horizontal line.
You guys have those 2 examples on there.
That's it. So these are a little different, but they're a lot easier. You don't need a table. Just a horizontal or vertical line.
Vertical supposed to be.
Yep. So now let's take a look at okay, let's look at x equals -2. Okay, I'm going to skip example 3b. Okay, I'm going to go, we did 3a, I'm going to go to 4a. What kind of line is this one? Victor?
Oh, I just know it goes over.
Yeah.
It goes over 2, right?
Which direction?
Left.
Good.
Left 2, and then is it vertical or horizontal?
Horizontal.
X equals?
Vertical.
Vertical. So,
Remember, it's on the x-axis, draw your line opposite. Opposite of the axis it says.
okay, so x equals vertical line, right where Victor said, at -2. Right, now let me just mark a couple coordinates on that. Let's mark this one. And let's mark this one. Anybody give me the coordinates for that bottom one? Well, this is, let me make this clear. That's my x, and that's my y-axis. So my origin is right here. What's this coordinate? Michaela? -2, 0. What's this coordinate above it? Yeah. Yeah, -2, 2. I just marked 2 coordinates. Is this a function? This picture that I just drew? No, why not?
Because the -2 appears twice.
Yeah, this appeared twice. So this is not a function. And vertical lines tell us a lot about whether something is or isn't a function. Okay, and this is called the vertical line test.
So that's the last thing on your notes, guys.
Okay, vertical line test is used if you have a picture and you want to determine if it's a function.
Then there's a line after we have to write something down. Don't worry about that yet.
So, what you do is you look at your picture, and if you can draw a vertical line and it hits your picture more than once, your picture is not a function. All right? So that's the part that you're going to be writing down that's highlighted. Okay? If you have a picture, I'll give you a picture of something on the test, and if you can draw a vertical line anywhere you want, and it hits your graph more than once, it is not a function. Right? So let's look at this picture.
So you can make that right hand paper. So all you're going to write for your vertical line test, if you're going to put intersects a graph more than once, it is not a function.
Right, let's look at this first one. Okay, I'm just going to put in some vertical lines.
And guys, this one right here will be the one on the bottom of the page on the far left. And we'll just work our way across for each example.
Okay, as I'm putting vertical lines in, does it ever hit the graph in red more than once? Any one of those vertical lines?
No.
No. No matter where I put it, it only hit the graph once. So what does that mean? If a vertical line doesn't hit it more than once, this is a function. Okay, no matter where I put a vertical line, it only hit it one time. What that basically means is the x doesn't repeat. The x value doesn't repeat. Okay, let's look at this one. Before I even put lines in, what do you think? Is a vertical line going to hit this more than once? Yeah, not if I put it right on the edge, but I can put it anywhere. It hits it more than once. Is this a function, yes or no? No, this is not a function. Vertical line hits more than once. How about this one? If I put vertical lines in, is it hitting it more than once?
No.
Nope. A horizontal line would. That's totally different. We don't care about that. So vertical line only hits it once. Is this a function? Yes, it is. Okay, and the last one. I think we looked at a shape like this yesterday. Is a vertical line hitting more than once? Nope. Would a horizontal line hit? Yeah, we don't care about horizontal though. So this is a function. Okay, so all you got to do is look at your picture, draw vertical lines. Doesn't hit more than once, you got a function. All right, so couple quick reminders.
Guys, homework's coming out on this paper. Go over it.
We're going to give you a review sheet you can use on the test tomorrow. The test is tomorrow because we have a half day on Friday. And there'll be a bonus question in the video tonight. Okay, so check out the video tonight. Right, so the bonus question for the test on Thursday, October 29th, will be let f of x equal 3x plus 2. I want you to evaluate that function when x is 5. Okay, so evaluate f of x equals 3x plus 2 when x is 5. On the test, okay, what we'll do is have you write down your answer to the above problem. This problem will not be on the test, so you need to copy down just your answer to this question on your review sheet. Okay, you will not be allowed to look back in your notes to help you answer this question during the test.